Hello and welcome dear students. I hope all of you have attended the JEE 2026 paper. Today I will be discussing the physics paper solutions from 21st January shift 1. So let's go to the first question. That is, consider a modified Bernoulli equation, and in this equation we need to find the dimensions of A and B. We need to find the dimensions of A and B. Okay. So the method is, when two quantities are added, their dimensions will be equal. Yes or no? So you can see from this bracket, in this bracket what is written? This quantity and this quantity, their dimensions must be equal. So we can write dimensions of H will be equal to dimensions of B into T. Yes. Now from this, what is the dimension of B? Dimension of B will be equal to nothing but dimension of H divided by dimension of T. Okay, so we can write the dimensions of B equal to, see, height, it is a length, yes or no? So length dimension is L and time dimension of time is T. So we can write the dimension of B as LT minus 1. Easy. The dimension of B is equal to LT minus 1. Okay, we got dimensions of B. Now we will find the dimensions of A. So from this bracket you can see this quantity and these two quantities are added, so their dimensions will be also equal. So we can write that dimensions of P must be equal to what? Dimensions of A divided by BT square. Now in this case, we know in the Bernoulli equation P represents the pressure, and how to find the dimension of pressure? So we can apply a formula, that is pressure equal to force upon area. Okay. And dimension of force is nothing but what? MLT minus 2, and area can be written as length into breadth or length square, so it is nothing but L square. So dimensions of pressure will be M, 1 and 1L will be cancelled, so ML minus 1, T minus 2. This is the dimension of pressure. Yes? Okay. So we can put the dimension of pressure here. So, okay, so from this equation dimension of pressure will be what? M L minus 1 T minus 2. Okay, and dimension of A we need to find, dimension of B we already got, LT minus 1, and dimension of T square is capital T square. Yes. So now solve this equation and you will get the dimensions of A. Okay, so let's solve. So see, we can write the dimension of A equal to how much? So if these things are divided here, so it will come this side and they will be multiplied each other. So dimension of A will be M. See, L to the power minus 1 and here 1 is L. So if these two terms are multiplied, then L to the power minus 1 plus 1 will be L to the power 0. Okay, and here T to the power what? T to the power minus 2, and this T to the power plus 2 will be cancelled, but 1 T to the power minus 1 will remain. So dimension of A will be MLT minus 1 and dimension of B will be LT minus 1. So option will be option 2. 2 is the correct answer. Okay, let's go to the next question. So a 4 kg mass moves under the influence of a force. This force is given like this, and we need to find the velocity and position after 2 seconds. Okay, so force is given and mass is given. So from this data we can find the acceleration. So acceleration will be how much? Acceleration will be force divided by mass. Yes or no? From Newton's second law, F equal to ma. So since force is given in vector form, so we can write A vector equal to F vector by m. Now see, force is given as 4t cube I cap minus 3t j cap divided by mass. Mass is given as 4 kg. So divide it. So A vector will be how much? So 4 will be cancelled. So t cube I cap minus 3t by 4 j cap. So this is the acceleration we got, but we need to find the velocity and position. Okay. So we got the acceleration. Now to find the velocity, we already know that acceleration is nothing but what? dv by dt, yes or no? So dv by dt is t cube I cap minus 3t by 4 j cap. So dt is divided, so we can multiply in that side. So left side will be dv equal to t cube I cap minus 3t by 4 j cap whole into what? dt. Okay, so to get the velocity we need to integrate both sides. Okay, so the limit will be initial time take 0 and final time take t. Now we need that at 2 seconds na? So we will put the value of t equal to 2 seconds at last. Okay, so it's fine. So integration of dv will be what? Integration of dv will be just v. Yes, v vector. And integration of t cube means kya hoga? That will be t4 by 4 I cap. Okay, then minus 3. Okay, 3 by 4. Next, integration of t will be what? T square by 2. Yes, t square by 2 j cap. Yes, okay. And we need to put the limit 0 to t. So you see, if you put the upper limit in place of t, so it will be remain as it is, and if you put 0, so lower limit, then it will get 0. So directly you can write velocity is nothing but t4 by 4 I cap minus 3t square by 8 j cap. So we can give this equation as 1. Okay, at last we will put t equal to 2 seconds because we need after 2 seconds. Yes, now we need to find the what? We need to find the position. So for position we also know that v vector is nothing but dr vector by dt. Yes, so that will be right side will be remain as it is t4 by 4 I cap minus 3t square by 8 j cap. So dt you take in the right side and then integrate. So integration integration dr. Okay, integration dr vector equal to integration t4 by 4 I cap minus 3t square by 8 j cap and then dt. Okay, so integration of dr will be what? Integration of dr will be r vector, and you also take the limit from 0 to t. Okay, now integration t4 by 4 will be, see, integration of t to the power 4 will be t to the power 5 by 5. Okay, t to the power 4 5 by 5, and already 4 is there. This will be I cap minus 3 by 8 is constant, and t square, integration of t square will be t cube by 3 j cap. Okay, and lower limit will be 0, upper limit will be t. Yes, if you put the limit, so it will remain as it is. Okay, so what will be I am writing here. So what will be my position vector will be t to the power 5 by 4 into 5 will be 20 I cap minus this 3 and this 3 will cancel each other. So t cube by 8 j cap. We have put in the upper limits and lower limits. Now we need to find at what? At t equal to 2 seconds. After 2 seconds, no? Yes. So put it. And this is equation number 2. Okay. First put it in equation number 1. So therefore equation 1 implies velocity equal to how much? So 2 to the power 4. 2 to the power 4 means what? 16. 16 by 4 will be 4. So that will be 4 I cap minus 3t squared. 3 into 2 squared. So 2 squared is 4. So 4 and 8 will be cancelled. So at the denominator we will have 2, so that will be 3 by 2 j cap. So we got the velocity at t equal to 2 seconds. Similarly, from equation number 2 we also get the position. Yes or no? So put t equal to 2. So 2 to the power 5 means 32 by 20 I cap minus 2 cube. 2 cube means 8 by 8 j cap. So directly that will be j cap. Yes or no? So r vector equal to, so you cancelled it, this will be 5, this will be 8. So 8 by 5 I cap minus j cap. Yes or no? So which option will be correct? So velocity 4 I cap minus 3 by 2 j cap, and r vector will be 8 by 5 I cap minus j cap. So option 2 is the correct answer. Yes? Okay. Let's go to the next question. Okay. So potential versus position graph is given, distance graph is given, and we need to order the rank the forces. Yes. Now how to solve this question? We already know a relation between potential energy and force. Yes or no? So we know that force is nothing but what? Minus du by dx. Okay. So you see, so you can take minus here or let it be. So if potential energy versus position graph is given, so from this graph if you find the slope, so slope we can write, slope can be written as what? Du by dx. We know differentiation of y with respect to x is nothing but what? Slope. So if you find the slope and if you take the negative of it, we will get the force. Or ultimately, to get the magnitude of force we need to take the modulus of this. Yes or no? So we need to see the slope and take it magnitude, and that will give the amount of force, magnitude of force. So from here, from this graph, this is potential energy and this is position. So from this graph we already can see that this has highest slope. Yes, this has the maximum slope. So slope of BC is highest, maximum. It is maximum. Okay, so its force will be maximum. Yes or no? Yes. Next, this is horizontal, and for horizontal curve, slope is how much? Slope is 0. So we can write slope of CD equal to 0. So force will be also 0. Yes. Now we need to see this slope and this slope. Okay, this slope is positive and this slope is negative, but we need to take the magnitude. But how to find which one is greater? So for OB, slope of OB can be written as what? Y, value of y divided by value of x. So this value will be how much? This value will be 1, and x value will be, this is also 1. So this slope will be 1. Okay, and the slope of DE will be, so this y value will be how much? If this is 3, this is 5, so this middle value will be 4. So this value will be 4 minus 3 will be 1, and this value will be what? This is 6 minus 4, that will be 2. Yes or no? The slope will be 1 by 2. Okay, but this slope is negative, but we need to take the magnitude only. Magnitude of the slope will give the force. Yes or no? Yes. So we can see from this data the BC has the maximum slope, that's why its force is maximum, and then the OB has second maximum slope, and that's why its force will be second position, and then we have half slope and 0 slope. So we can write the force of what? Force of BC will be maximum, then force of OB because it has slope 1, and then force of DE, and then at last we have force CD because it has 0 slope. Yes or no? So this will be the right answer. So answer will be option D. Very simple question. Okay, let's go to the next question. So in this case, two springs are given and these springs are connected in parallel. Okay, see, if two springs, okay, with spring constant K1 and K2 are connected in parallel, let us consider this block is connected. Okay, so we can replace this combination by a single spring of equivalent spring constant. Okay, of equivalent spring constant equal to what? There will be just addition, K1 plus K2. This is the main rule. Okay, if two springs are in parallel, their equivalent spring constant will be just added. So we can write therefore K equivalent is nothing but K1 plus K2. Okay, so take this value is 10 and this value is 20. So that will be K equivalent will be how much? K equivalent will be 30. Now, okay, now from this equation you take the derivative of K equivalent can be written as delta K1 plus delta K2. Okay, this means change in K1 is how much? 0.2. You take only the magnitude plus change in K2 is how much? 0.3. So that will be total 0.5. Okay, now we need to find the percentage error in equivalent. Okay, so therefore percentage error in K equivalent will be how much? That will be delta K equivalent change divided by original value into 100%. Yes. So that will be 0.5 and this will be how much? 30 and this will be 100%. So if you calculate, so you will get approximately 1.67%. Yes. So this will be the answer. Okay, let's go to the next question. Okay, so a rod is there of length L and it is suspended with the help of two strings. Okay, now if one string is cut, okay, so if one string is cut, if we cut this string, then what happens? This rod will rotate about this point. Yes or no? The rod will rotate about this point, so it will have an angular acceleration alpha. Yes or no? Yes. Next, okay, so the center of mass will be at the center because it is a uniform rod. This will be the center of mass. So one force will be there, mg. Yes. Let me draw it again. So this is the rod. Okay, and there was a string, and this string has been cut. Okay, so that's why this rod will rotate about this point, and that's why it will have an angular acceleration alpha. And this is the center of mass at the center, so there will be a weight. Yes or no? So we need to find what? We need to find the tension on the other string. So if this string is cut, so we need to find the tension at this string. Okay, so let me draw the direction of tension. Tension will be in this direction. We need to find this value. Okay, now how to find? So we can see that this rod will rotate. Okay, so center of mass will also come downward. Yes or no? So if you see the translational equation, we can write that downward force means the center of mass will come downward. It will have obviously some acceleration. Yes or no? So let us assume that acceleration will be A. So downward force minus upward force will be how much? Ma, because we can apply Newton's second law. F net equal to what? Mass into acceleration. So F net means downward, since the center of mass is going in the downward direction, so downward force will be greater. So mg minus upward force in this rod will be T equal to mass into acceleration of the center of mass. Okay, so from this equation we need to find the tension. So tension will be how much? Tension will be nothing but N G minus Ma. Okay, so take M comma, so G minus A. So this is the, okay, but this is not given in any option, so we need to find the value of A, acceleration of the center of mass. Okay, we will find and then put. Now see how to find this. Now we have applied the translational equation. Now we can apply the rotational equation in this case. Since there is a rotation, so of course there will be a angular acceleration alpha. Okay, so we can write net torque about any point equal to moment of inertia into alpha. Yes or no? So I am considering this. Point. Okay, I am writing net torque about this point because this rod will rotate about this point. So I am considering this. So at this point, this force is passing through this line. So we may not consider this force tension. Okay, so only this mg will rotate this rod about this point. Okay, so we can write the torque equal to force into perpendicular distance. Force is mg, and what is the perpendicular distance? Perpendicular distance means this distance. Since total length is L, so this will be at the center, so this distance will be L by 2. So mg L by 2, okay, equal to I means moment of inertia of the rod. Since this is one corner of the rod, so moment of inertia will be m L square by 3, and alpha, let it be alpha. Okay, let it be alpha. So since cancelled, 1L will be cancelled, so 3g by 2L, that is the value of alpha. Okay, 3g by 2L, that is the value of alpha. But we need to find the value of acceleration A. Now see, I am drawing here. Okay, I am drawing here. Okay, Just consider the half length. This is L by 2. We are considering this length only, and this rod is rotating about this point, so it will have an angular acceleration alpha. So if a rod rotates about this point like this, so at this point we have an acceleration, yes or no, tangential acceleration in this case. So this tangential acceleration can be written as distance into angular acceleration. Distance is how much? Distance is L by 2 and angular acceleration is alpha. So A will be L by 2 into alpha, and this is the center of mass of the point. Okay, so we already got A equal to how much? L by 2 alpha. So in equation 1 we can put, so I am erasing these things. Okay, so from equation 1, okay, I am writing the equation 1 again. Sorry. Okay, I will write the equation 1 again. So equation 1 says T equal to m g minus a. This is the equation 1. Now see, T equal to m g minus, what is the value of a? A is nothing but L by 2 alpha. Okay, now see, m g minus L by 2. What is the value of alpha? Alpha you got 3g by 2l. So 3g by 2l. So here L will cancel, and this will be 3g by 4, means m g minus 3g by 4. Take the LCM. We take the LCM 4. So 4g minus 3 will be g by 4. So answer will be m g by 4. So option number 2. This is the answer. So this is easy question, but it takes some time. Okay, let's go to the next question. Now water flow in a tube. Okay, the difference in height, okay, this is also given. So we need to find the rate of flow. Okay, we need to find the flow. So how to solve this equation? First we can write this, since fluid is flowing from, means it is flowing in the right side. Okay, so we can write the flow at point A and flow at point B will be equal, yes or no? So we can write from continuity equation, we can write the flow at point A, and flow formula is how much? Flow is nothing but area at point A and velocity at point A equal to area at point B. Velocity at point B will be equal. Okay, and area at point A is given as how much? This area is given as 6. Okay, so 6 VA equal to area at point B is given as 3 VB. So from this we got 2 VA equal to VB. So this is equation number 1. Okay. Now we can use Bernoulli's equation. In this type of question, always use a Bernoulli's equation. Okay, so using Bernoulli's equation, we get at point, using Bernoulli's equation at A and B. At points A and B we will get, so PA plus half rho VA square, plus we can write rho GS, but both the points are at the same height, yes or no? So this term will be cancelled. So no need to write this term, potential energy term. So we can directly write PB plus half rho VB square. Third term will be cancelled because they are at the same level. Okay, now see, what is the pressure at point A? Pressure at point A and pressure at point B. Let's find. So since there is atmosphere, so it will give the atmospheric pressure. We are considering P naught. Okay, and let this distance be h. Okay, so this distance will be how much? This total distance will be, this will be 5 centimeter and this will be h. Okay, let us convert into SI unit. So it will be 0.05. Okay, plus h. Yes, and here atmosphere will get pressure of P naught. So PA can be written as P naught plus h rho g, and this height will be 0.05 plus h rho g. Sorry, this h rho g. Yes. Now see, plus half rho VA square equal to PB, pressure at point B. At point B क्या होगा? So atmospheric pressure plus h rho g, that will be P naught plus H rho G plus half rho VV square. So can you see one term, that is P naught is directly cancelled, and then this H into rho G and this H rho G will be cancelled, yes or no? So this will be cancelled. So in the left hand side we will have only, okay, we will have only 0.05 rho G. Okay, also rho can be also cancelled because it is present in all the terms. Okay, rho can be also cancelled, so you can write 0.05 G plus half VA square equal to, this will be how much? Half VV square. Okay, okay, next I'm doing here again. So from this equation, what you can write, we can take 0.05 G in the left hand side and we can take this term in the right hand side. So we can take half common, so that will be VB square minus VA square. Yes. Now 0.05 we can take, G is given, G is given as 10, so you can take 10. Okay, now half, what is the value of VB? VB is nothing but 2VA, so VB square means 2VA ka whole square, that will be 4VA square minus VA square. Okay, so that will be 0.5 and this will be 4VA square minus VA square, that will be 3VA square, so 3 by 2 VA square. Okay, just solve it to get the value of VA, velocity at A. Now 2 will come here, so 0.5 into 2, that will be 1, so 1 by 3, so that will be 1 by 3 VA square. We need to find the value of VA, so VA will be 1 by root 3 meter, but at the answer we need to convert it into centimeter cube per second. So let us convert it into centimeter, so that will be 100 divided by root 3 centimeter per second. This is the velocity at point A. Okay, now we need to find the flow. Okay, since flow is same at all points, so let us find the flow at point A. Okay, therefore rate of flow we are finding at point A, so that will be VA into AA, या फिर AA VA, whatever. So VA is 100 by root 3 and A is given as 6 and all are in centimeter square. Okay, so that will be how much? That will be 100. Okay, root 3 and 6 can be written as root 3 into root 3 into 2. So you can see 1 root 3 will cancel, so 2 into 100, 200 root 3 centimeter cube per second. This is the answer. So option is 3. Very easy question, but it takes some time. Okay, let's go to the next question. Okay, there are two rods of same length are joined to make the total length of 120 centimeter. Okay, let us consider this is what, aluminum rod, and this is also steel rod, but their length are same. Since total length is given as 120 centimeter, so individual length will be 60 centimeter and this will be also 60 centimeter. Okay, now they are initially present at 30 degrees Celsius. Okay, and their coefficient of linear expansions are given. Okay, next, the length of the composite rod when its temperature is raised. Okay, temperature is increased from 30 degree to 100 degrees Celsius. So change in temperature will be how much? 100 minus 30 will be 70. Okay, so therefore the final length LT can be written as, first what will happen, this rod will be expanded, so we can write the expanded length formula for aluminum, and then this rod will be also expanded, yes or no, if temperature is increased. So both rod will be expanded, so we can write the individual expanded length formula and then we can add. So that will be, we are taking this length is L0. Okay, individual length is L0, this is also L0. let us consider this is LT. So this will be L naught 1 plus alpha aluminum delta T plus L naught 1 plus alpha steel delta T. Okay, now as you can see both the rods have same length, so we can take L naught common. So if you take L naught common, this will plus will be this, so 1 plus 1 will be 2 plus, if you take delta T common, so we'll, in the bracket we will have alpha L plus alpha steel. Okay, okay, next L naught individual length will be how much? 60 x2 plus delta T is 70. Okay, and alpha aluminum is given as 24 into 10 to the power minus 6 plus, see this is given in 10 to the power minus 6 and this is given in 10 to the power minus 5. Let us convert it into 10 to the power minus 6. minus 6 हो जाएगा तो क्या होगा, इधर 10 से मल्टीप्लाई करना पड़ेगा. We will get 1.2 instead of 1.2 we will get 12 into 10 to the power minus 6. Okay, just add them and calculate. So you will get the answer approximately, let me see, you will get the answer approximately 120.15 centimeter. Option 2 is the correct answer. Yes, easy. Okay, let's go to the next question, that is two strings A and B have linear densities. Their linear densities are different, lengths are given 2.5 meter and 1.5 meter. Let us draw. This is 2.5 meter length, 2.5 meter. This is string A and string B has 1.5 meter length and they are joined together. So they are joined together, but this length is small, 1.5 meter. Okay, this string is B and their free ends. Okay, their free ends are joined with the help of two supports. Okay, these supports are C, D. Now, okay, now a tension is there of 500 Newton. Okay, 500 Newton का tension है in the whole wire. So two identical pulses sent from C and D. Okay, means we have sending one pulse from C and we have sending one pulse from D. Okay, and take T1 and T2. Means this pulse will take time T1 to come at this joint and this pulse will take time to come at this joint T1 and T2. And we need to find the ratio of T1 and T2. Now we need to find the individual time T1 and T2 and then we need to take the ratio. So how can we do? So we can first find the velocity of the first pulse. That can be written as root over T by mu A, because tension is same na? So we can write in just T. Tension is given as 500. Okay, and mu A is given as how much? 2 into 10 to the power minus 4. Okay, just solve it. That will be 5 into 5 root 10 into 10 to the power 2 meter per second, and VV equal to how much? T by mu B. Tension will be same na? So 500 by, okay, and mu B is given as how much? 4 into 10 to the power minus 4. That will be 5 root 5 into 10 to the power 2 meter per second. We got the velocity. Now use the speed and speed formula. Okay, since speed of pulse A can be written as this pulse will take time T1 and the length is how much? Length is 2.5 meter. So we can write LA by T1. So from here we can find T1. T1 will be how much? LA by VA. That will be LA is given as 2.5 meter and VA is, we already got 5 root 10 into 10 to the power 2. Okay, so T1 you will get okay, let it be, and T2 will be how much? T2 will be LB by VB. Yes, LB is 1.5 meter and VB, velocity of pulse B, will be 5 root 5 into 10 to the power 2. Okay, just you need to take the ratio. So divide it T1 by T2. Therefore what? T1 by T2. T1 by T2. So you can calculate, yes. So 2.5 divided by 5 root 10 into 10 to the power 2, and T2 will be 1.5 divided by 5 root 5 into 10 to the power 2. If you solve this, so you will get approximately how much? You will get 1.18. So answer will be option D. Okay, very easy question. Next. So in this question, so let us consider this is a earth. Okay, this is earth. Okay, a satellite is there from the center of the earth. That distance will be, let us consider r initial, that is 1.5 times radius of the earth. A satellite is there at this position. Okay, let us consider this mass to be m, and this is given as 100 kg. Okay, now this satellite has to be moved with a circular orbit of radius. That radius will be how much? Let us take RF, and it is 3 times radius of the earth. Okay, so how much energy will be needed? So we can find the energy at this point. This is the initial energy, and at this orbit this will have final energy. So if you give the change in energy to the satellite, then satellite can get from this orbit to this orbit. Yes or no? So we know the energy of satellite. Energy of satellite at any circular orbit can be written as E equal to minus Gmm by 2r. M is the mass of the earth, small m is the mass of the satellite, and r is the distance of the satellite from the center of the earth, or it can be written as the radius of the circular orbit. Okay, so therefore initial energy can be written as EI equal to minus Gmm divided by 2r initial, and that is minus Gmm divided by 2. What is r initial? That is 1.5 Re, that is nothing but minus Gmm by 3 Re. Yes, okay. I will let it be. We will solve at last. Okay. Next, therefore, final energy E final equal to minus Gmm divided by 2r final. That will be minus Gmm divided by 2. What is the r final? R final is the 3 Re. Okay. So we need to give change in energy of these two orbits. Yes. So therefore required energy to move the satellite from initial orbit to final orbit, that is nothing but what? That will be delta E. Delta E is nothing but final energy minus initial energy. So take it minus Gmm by 2 into 3 Re minus, and initial energy will be minus Gmm divided by 2 into 1.5 Re. Okay, so from this we can take common minus Gmm by 2 Re is common, so that will be 1 by 3 plus 1 by 1.5. Okay, minus Gmm by 2 Re. So take LCM. Okay, first solve it. 1.5 can be written as 3 by 2, so 3 will remain here and 2 will go in the above. Okay, so minus Gmm by 2 Re. So take LCM 3. So 1 plus 2 will be 3. Okay, so this 3 and this 3 will be cancelled. Oh, sorry, I have done a mistake here. So if I take minus common, so there will be a minus here. Yes. Okay. So this will be this. So if you take 3 LCM, so 1 minus 2 will be minus 1, and this minus will be plus. So Gmm by 6 Re. Okay. Okay. Now we need to find. Okay. This energy is given in terms of alpha. Okay. Let us calculate. See, the acceleration due to gravity at the Earth's surface can be written as g m by what? R e square. Yes or no? So from here, so take one re at this side, so that will be g into re, and it will remain g m by re. Yes. So in this equation, g m by re we can write as small g re. Okay. So from this what I can write, therefore change in energy is nothing but what? G re, okay, into m, mass of the satellite, divided by 6. Okay, g is given as how much? 10. Okay, radius of the earth is given as 6 into 10 to the power 6. Mass of the satellite is given as 100 kg and divided by 6. Okay, so this 6 cancel, and if we see, this will be 1000 into 10 to the power 6 joule. Yes or no? 100 into 10,000 and 10 to the power 6. So we need to find the value of alpha. So see this equation and we can compare with alpha into 10 to the power 6. Yes or no? So alpha will be nothing but 1000. So in this case, alpha is 1000. See, very simple question. Okay, let's move to the next question. So in this question, we need to find the moment of inertia about point A. Okay, how to find? Okay, two rods are connected. So you can see the moment of inertia of this rod about this corner will be how much? Let us consider this is I1. I1 will be how much? I1 will be ml square by 3. Okay, because moment of inertia about its corner will be ml square by 3. Now take this rod. This is rod number 2. This is 1. This is number 2. Okay. Now we need to find the moment of inertia about this point. Okay, let us find the moment of inertia about the center of mass. If this rod is rotated about center of mass, then the moment of inertia ICM, that can be written as what? That can be written as ml square by 12. Okay, now this is one axis and we need to find the moment of inertia about this axis. So we can use perpendicular axis theorem. So moment of inertia about this axis will be how much? Moment of inertia at the center of mass plus m into this distance square. Yes or no? So moment of inertia, just I2 for this rod 2 will be about this axis, will be I2 will be I center of mass plus m into distance between these two parallel axes. Yes or no? Sorry, we can use the parallel axis theorem. Parallel axis theorem. So the distance between them will be total L. So m L square. Okay, just put. So ICM will be how much? M L square by 12 plus m L square. So total moment of inertia about the point O will be how much? That will be I1 plus I2. That is m L square by 3 plus this is m L square by 12 plus ml square. So take the LCM is 12, take ml square common, so that will be 4 plus 1 plus 12. So that is 4 plus 1 5, 5 plus 12 is 17 by 12 ml square. So we need to find the value of x. This is given as x by 12 ml square, and we need to find the value of x. So x will be how much? X will be 17. So the answer will be 17. Okay. Let's go to the next question. That is, in this question, 10 mole of oxygen gas given, number of mole equal to 10 moles of oxygen gas it heated at constant volume. So temperature changes from 30 degrees Celsius to how much? 40 degrees Celsius. So the change in temperature, delta T will be how much? Delta T will be how much? 10. Next, the change in internal energy of the gases. Okay, we need to find what? We need to find delta U, and we know the formula of delta U is N CV delta T. Okay, so N CV here CV is not given, here CP is given. Okay, so we already know the relation between CB and CP minus CV equal to R. So from here CV equal to CP minus R. So CV can be written as CP minus R into delta T. Okay, N is given as 10, CP is given as how much? CP is 7, R is given as 2, and delta T is 10. So 10 into 10 will be 100, 100 minus 9 will be 7 minus 2 will be 5. So 500 calorie. So answer will be 500. Yes, very easy question, direct question. Yes or no? Okay, let's move to the next question, that is a parallel plate capacitor has capacitance C. Okay, a parallel plate capacitor has capacitance C when air is there. Okay, next, a sheet having thickness 1/3 of the separation means, okay, so if this area is A and this thickness is D, we can write C is epsilon naught A by D, capacitance of the parallel plate capacitor. Now what happens between these two plates of the capacitor? What we have done? We have inserted a dielectric. Just its length is 1/3 of the separation. Means if the separation is D, so this distance will be D by 3, and remaining distance will be how much? 2D by 3, yes or no? But you can see the area remains same. So area, if initial area is A, so final area will be also A. So in this type of question, dielectric, when there is dielectric, so we can break the capacitor into many capacitances. Okay, so we can assume that there is one capacitor and there is one capacitor. So we can assume that there is a capacitor with a dielectric and another capacitor with air. Okay, so let us consider this value is C1 and this value is C2. Since dielectric constant how much? K is given, so we can take it as K. Okay, and these two are in series, then we can find the equivalent capacitance. Now first find the value of C1. Okay, C1 will be how much? C1 will be first, since dielectric is there now, so whatever the capacitance is, K will be multiplied. So K, now you can apply the parallel plate capacitor formula. Epsilon naught, area is A, and what is that? This distance of separation is D by 3. Okay, so just simplify it. So you will get C1 equal to 3K epsilon naught A by D. And since epsilon naught A by D we have taken as C, yes or no? So this C1 will be nothing but 3kc. Okay, C1 is 3kc. Now we need to find the value of C2. We are finding the value of C2. Therefore C2 will be how much? Since air is there, so no dielectric constant, so epsilon naught A by, but the distance is, what is the separation between them? This 2D by 3. 2D by 3. So that will be what? That will be how much? 3 epsilon naught A by 2D. And since epsilon naught A by D is nothing but what? C. Yes or no? So we can write it as 3C by what? 3C by 2. So C1 and C2 we have found in terms of C. Okay, so see, these two capacitors are in parallel, so their equivalent capacitance can be written as like this. The equivalent capacitor becomes C equivalent equal to C1 into C2 divided by C1 plus C2. This is the shortcut formula for equivalent capacitances in series. So C1 is how much? C1 is 3kc, okay, into C2 is 3c by 2. Next 3kc plus 3c by 2. Okay, multiply numerator and denominator by 2. So these 2 will be cancelled. So in the numerator we will be having 9kc square, and since we have multiplied with 2, so 2 into 3 will be 6kc, and 2 will be cancelled, and that will be 3c. Okay, so what we can do? We can take at the denominator we can take 3c common, so that will be k plus 1, sorry 2k plus 1, and at the numerator 3kc square. So what will be, there is 1c will be cancelled, and this 3 and this will be cancelled. So in the numerator we will have 3. So that answer will be 3kc divided by 2k plus 1. This is the answer. So yes, option A is the correct answer. Okay, very easy question. Next, let's go to the next question. That is the heat generated in 1 minute in the given circuit. Okay, So I can see that this is a balanced Wheatstone bridge, because if you multiply these terms, so 1 into 4, that will be 4, and this diagonals 2 into 2, that is 4. So this is balanced Wheatstone bridge. So what you can do? We can do remove this middle term, yes or no? So if you remove this middle term, so we can see that these two resistances will be in series and these two resistances will be in series, and the equivalent resistance become, this will be 1 plus 2 will be 3 ohm, and then 2 plus 4 will be 6 ohm. Okay, now see the combination here. This is 2 ohm and this is 6 ohm. Okay, their equivalent resistance becomes, so R equivalent will be just 2 into 6 divided by 2 plus 6, and that will be 3 ohm. Okay, now see, this whole combination can be replaced by a 3 ohm resistance. So let us draw the final circuit diagram. This is 3 ohm, and then a battery is there of 9 volt. Okay, but the battery has some internal resistance of 1 ohm. So this has some internal resistance of 1 ohm in the battery. So in the diagram it is not given, but it mentioned in the question. So it is the battery. Okay, so let's find the current flowing in this circuit. Okay, current flowing. So we can use Ohm's law. Ohm's law use करेंगे तो क्या होगा? V equal to I into R equivalent. Okay, see, total is 9 volt, current I. What is the total equivalent resistance? This is 3 ohm and this is 1 ohm. They are connected in series. Their equivalent resistance will become 4. 3 plus 1 will be 4 ohm. Oh, sorry. This equivalent resistance, I made some mistake. Yes, this will be 1 plus 2 will be 3 ohm and this is 6 ohm. So 3 into 6 divided by 3 plus 6, that will be 2 ohm. Okay, sorry, it's my mistake. So at this point we will have 2 ohm resistance and then 1. So total equivalent resistance will become 2 and 1, that will be total 2 plus 1 will be 3. Yes, so that will be 3 ohm. So from this we can find the value of current as 3 ampere. Okay, now we need to find the heat generated in 1 minute between the points A and B. Point A is here and point B is here. So we need to find the heat. So what is the formula of heat? So formula of heat produced is equal to I square R into T. Yes. Okay. So current is how much? 3 square. Resistance is how much? 2. And what is the time? 1 minute. 1 minute means how much? 1 minute means 60 seconds. So that will be 3 square means 9. 9 into 2 means 18. 18 into 6 means 54. 540 joule. This is the answer. Let me check. Okay, the answer is, so the answer is 1080 joule. Okay, just calculate, you will get 1080 joule. Okay, let's go to the next question. That is, a conducting circular loop of area 1 meter square is placed perpendicular to a magnetic field which varies. Okay, here magnetic field is given like this and area is given like this. Since magnetic field is changing, that means what? Friends, flux is also changing. So we can write the flux, total flux is what? B dot A vector. Okay, let us consider these are the magnetic field lines, inward magnetic field lines. Okay, but they are varying. Okay, they are not constant. And area, let us consider this is circular area, and this area is perpendicular to the magnetic field lines, yes or no? But area vector will be outside or inside. So let us consider the inward area vector. So if I consider inward area vector, then inward magnetic field is also inward and area vector is also inward. So angle between them will be 0 degree. So we can write BA cos how much? 0 degree. Yes or no? So phi equal to B. Magnetic field is given as sine 100t. Area is how much? 1 meter square and cos 0 is 1. So that is phi equal to sine 100t. Okay. Now what we need to find? We need to find the average thermal energy. Okay. Now let us find the induced EMF or voltage. Okay. Epsilon induced, or directly we can call it as voltage. That is nothing but what? Actually we need to take minus d phi by dt, but we will take just magnitude only. Okay. So see, minus just take the magnitude, differentiate it and take the magnitude. Let's say so d by dt of sine 100t. Yes. Okay. So differentiate it and get the value of voltage. So voltage will be how much? Voltage will be sin का differentiation क्या होता है? Cos 100t. Okay, but this 100 will come outside. So this will be V equal to 100 cos into 100t. Yes. Okay. So we got the value of voltage. Now we can calculate the power. We can calculate what? We can calculate the power. So power is nothing but what? Power has many formulas, so here we can use, we already got voltage, so and resistance is given, so we can use power equal to what? V square by R. Okay, so V is given as 100 is square cos is square 100t divided by cos is square 100t divided by R. R is how much? R is 100. Okay, so this 100 and this one will cancel, so power will be 100 cos square 100t. Okay, now we need to find the average thermal energy. Now we need to find the average thermal energy. So that will be nothing but equal to integration of power dt. Okay, so take limit 0 to 1 time interval. Okay, now see 0. What is the value of time period capital T? Since it has this sine of omega t. What is the omega? Omega is 100 here. Okay, so and we know t equal to 2 pi by omega. So that will be how much? 2 pi by 100. That means pi by 50. Yes or no? So that will be pi by 50. This is the time. And power is given as 100 cos square 100t dt. Okay, so you can see 100 will come outside. Okay, now 0 to this pi by 50. Now cos square 100t can be written as cos 200t minus 1 divided by 2. Use the formula of cos 2 theta. Okay, and if you do the integration, you will get so 100 will be outside, and you will get whatever the limit that will be just half. Okay, so take pi by 50 and take the half of it. This is the direct shortcut. Okay, so what is the shortcut? Whenever we take the integration of cos square some theta or cos square omega t sin square omega t, the answer will be whatever the time period, take the half of it. Okay, so what? This 100 and 50 into 200, 100 will be cancelled, but that will be pi. So average thermal energy will be pi joule. So that answer will be pi. Option 3 is the correct answer. Okay, let's go to the next question. That is a current carrying solenoid. Okay, current carrying solenoid is placed vertically. Okay, there is a solenoid. Okay, and current is flowing inside. Okay, let us consider this is the direction of current. Okay, now a charge of mass small m, a charge is there. Okay, this mass small m and charge q is present, capital Q. Okay, this is moving downwards. Yes or no? Moving downwards with an acceleration g. Okay, due to gravity. Then okay, see. So since current is flowing in this loop or in the solenoid, so it will produce what? It will produce a magnetic field. Yes or no? And we know that magnetic field applies some force on any charge, and that will be Fv equal to how much? Fv equal to Q V cross B. Yes. Okay. So if we find the magnitude of this force Q V sin theta. Yes or no? Now what is theta? Theta is the angle between velocity and magnetic field. Okay, so the magnetic field of inside the solenoid will be either upward direction or maybe in the downward direction, depending on the direction of current. Yes or no? So in this two way magnetic field can be there. Okay, but charge is moving in the downward direction, so its velocity is always downward. Yes or no? Velocity is downward. So if magnetic field is upward direction, so their angle between them is theta will be 180 degree. Or if magnetic field is downward, then velocity and the direction of magnetic field will be in the same direction. That's why the angle between them will be 0 degree. In both the cases, sine 180 degree or sine 0 degree will be zeros. That means solenoid will not apply any magnetic force on the charge, because since it is not applying any force on the charge, that means the charge will move just because of acceleration due to gravity. That means this acceleration will be same as g. Okay, so answer will be option A. Clear? Okay, let's go to the next question. That is a 1 meter long metal rod of this complete circuit. Okay, the area of the circuit is this. If the resistance of the then the find. Okay. Okay, since magnetic field is there and we are moving this rod in the right direction, so what is happening? So flux is changing. Because flux is changing, that means some induced EMF is produced in the rod, and that's why the current will flow. Because of this, let us consider direction of current is in this direction. Okay, so so this magnetic field will apply a force on the rod. Okay, apply a force on the rod, and the direction will be FB can be written as what? FB vector can be written I L vector plus B vector. Okay, so the direction of L vector will be same as the direction of current on the rod. So L vector is this and B vector is inward. So L cross B will be left side. So magnetic field will apply a force on the left direction, FB. Okay, so if magnetic field is applying force on the left direction, but we need to take the rod in the right direction with constant speed, that means we need to apply some external force. Okay, we need to apply some external force and we need to find the value of this force. And since this rod should move with a constant speed or constant velocity, that means this force must be equal to this. That means net force on the rod must be equal to 0. Yes or no? So we can write that our net external force will be equal to the magnitude of this FB. Okay, now see, FB equal to nothing but I. Take this magnitude will be LB sine. What is the angle between L vector and B vector? L vector direction is upward and B vector is inward. So that angle is 90 degree, sine 90 degree. Yes, this will be ILB. Now how to find this current? Since this rod is moving with some speed V, so it will produce an induced EMF. Yes or no? If it produce induced EMF or motional EMF. Okay, we're considering that is epsilon, and that will be nothing but BVL. Okay, B is the magnetic field, V is the speed of the rod, and L is the length of the rod. So, and according to Ohm's law, V equal to IR, I into R. So from here, what I can get I equal to epsilon by R. Yes or no? So I can be written as epsilon by R, and epsilon is nothing but BVL divided by R. So I can be written as BVL divided by R into L into B. So if we see this, so it will be B square V L square divided by R. So all the values are given, so put them. So what is B? Magnetic field is given as 0.1. Okay, 0.1 Tesla. So this is square into what is the speed? Speed is how much? Speed is 1.5 meter per second. Okay, and the length of the rod is 1 meter divided by resistance is given as 2 ohm. So if you put all the values, you will get the answer. Let me check. You will get the answer of how much? You get the answer of 7.5 into 10 to the power minus 3 Newton. So option D is the correct answer. Okay, very simple question. Okay, let's go to the next question. That is, the electric field is given of an electromagnetic wave like this. From this we can see the electric field is propagating along y-axis. Okay, the vibration is oscillating along y-axis and the electromagnetic wave is going along x-axis. So we can say that magnetic field will oscillate or propagate along z-axis. That will be Bz. So directly we can neglect these two options because this is By and this is also By. Okay, and since the phase of the electric field and magnetic field will be same. Okay, there should be no phase difference. So whatever written inside the electric field, that will be also constant. Okay, that means we can directly say this will be the answer. Option A will be the answer. But let me calculate. Let me check. This is the answer or not. Okay, so from this equation, what is the magnetic electric field? That is 69. That means E naught is 69. Okay, let us find V naught. V naught will be how much? So we know a relation between electric field and magnetic field, that is C equal to E naught by V naught at any point you take. Okay, so what will be V naught? V naught will be E naught by C. Okay, and E naught is how much? E naught is 69. Okay, C is 3 into 10 to the power 8. So you just calculate, you will get 23 into 10 to the power minus 8. So it is given in 10 to the power minus 7. So you divide by 10, so that you will get 2.3 into 10 to the power minus 7. Okay, so magnitude of magnetic field will be, peak magnetic field will be 2.3 into 10 to the power minus 7, and we will be as it is sign, and inside whatever written, that is 0.6 into 10 to the power 3 x minus 1.8 into 10 to the power 11 t. Very simple question. So option what? Option A is the correct answer. Very simple question. You can solve it in 5 seconds. Okay. Next. See this question. A light wave that discussed by is here the energy. Okay. And two sinusoidal signals are given, falls on a metal surface of work function. Okay. So something is given, we need to find the maximum kinetic energy of ejected photoelectron. Yes, these questions came from the chapter Dual Nature of Matter. So see, since two lights falls on the metal, but we need to take the frequency, highest frequency. So this frequency omega 1 will be how much? Omega 1 will be 3 into 10 to the power 15 radian per second. Okay, and omega 2 will be how much? This is 12 into 10 to the power 15 radian per second. Okay, we need to take the maximum frequency. So maximum frequency will be this. Therefore, omega max, we need to take this as omega 2. Now we need to find the frequency. We know 2 pi f max equal to what? Omega max, and omega max is given as 12 into 10 to the power 15. Okay, so from here you can find the f max. Okay, from here you can find the value of f max. That will be what? That will be 6 by pi into 10 to the power 15 hertz. Okay, this is the maximum frequency. Now it falls on a metal surface of work function. Therefore, phi is given as 2.8 electron volt. So we need to find the maximum kinetic energy. So from Einstein equivalent photoelectric equation, we can write that maximum kinetic energy of the photoelectron, that is nothing but h nu minus phi. Yes. Okay. Now see, what is Planck's constant given? 6.6 into 10 to the power minus 34. Now nu is how much? 6 by pi into 10 to the power 15. But this will be in joule, but we need to find it electron volt, convert it into electron volt. Since 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. So 1 joule will be how much? 1 joule will be 1 by 1.6 into 10 to the power minus 19 electron volt. So we need to divide by 1.6 into 10 to the power minus 19 electron volt. So this will be in electron volt minus phi. Phi is given as 2.8 electron volt. So if you solve this, you will get around 5.1, I guess. Let me check. Yes, you will get approx. Okay, you will get 5.1 electron volts. So option A is the correct answer. Okay, let's go to the next question. That is a point charge of this is placed at origin. Okay, let us consider this is the origin. X-axis, y-axis. This is the origin. A point charge, let it Q1 is placed. Now, what is the work done in moving a charge of 2 microcoulomb from this point to this point? Let us consider this point is A, 4, okay, and this point is B, 2, 2, 1. Okay, so we need to move a charge from here to here. Okay, so this is the initial position, this is the final position, and we need to find the work done, means yes, work external, whatever. So how to do? So we can see since if there are two charges, then there will be potential energy in between them, yes or no? So we can find the potential energy in between them, that will be U initial, and if the charge is moved into final position, that potential energy between them will be U final, and whatever the difference in the potential energy, that will be the required work done. Okay, so we can write that work external is nothing but the change in potential energy, that means U final minus U initial. Now what is U initial? U initial will be K Q1 Q2 divided by R initial, and U final will be K Q1 Q2 divided by R final. Okay, now it will be K Q1 Q2, okay, divided by R final minus K Q1 Q2 divided by R initial. So take the common terms, K Q1 Q2, that will be 1 by R final minus 1 by R initial. Okay, now see, K is given as how much? K is 9 into 10 to the power 9. Q1 is how much? 10 to the power minus 8. And Q2 is how much? 2 microcoulomb, that means converted into SI unit. So this, now what is 1 by R final? Okay, and what is R initial? Let me check. Okay, see, Ri is nothing but the distance between the two charges, initial charges. Okay, so this distance will be how much? R initial, and this distance will be R final. So since this charge is at origin and charge 2 at this point initially, so we can use the distance formula. R initial will be nothing but x2 minus x1 square, means 4 minus 0 square, that is 4 square, plus y2 minus y1 square, this is 4 minus 0, 4 square, plus z2 minus z1, that is 2 square, that is how much? 16, 32, 6. So that will be 6. Okay, Ri is 6. Next, what is R final? Equal to root over x2 minus x1 square, that is 2 minus 0 square, 2 square, plus 2 minus 0 square, 2 square, plus 1 minus 0 square is 1 square, that is you will get 3. Okay, R final is 3. So you put here, so that will be R final is 3, and that will be 6. So you solve it, you calculate it. Okay, so you will get how much? So I am solving here only. See, okay, let's continue this question. So this will be 9 into 2 into 10 to the power how much? 9 minus it will be plus 1. So this will be 10 into 10 to the power minus 6. And if you take the LCM as 6, so this will be 2 minus 1, that will be 1. Okay, so you can see that 3 to the 2 times 2 will cancel. So this will be 330 into 10 to the power minus 6. Okay, yes, this much of joule. So answer will be how much? Answer will be option 3. Yes. Okay. Let's go to the next question. That is, okay. Let's see this circuit. This is what? This is nothing but OR gate. Okay, and this is NOR gate. Okay. If we apply same input, okay, if we apply same input, for example, if we apply A, so here it is coming A, here it is coming A. So what is the output of NOR gate? That is A plus A whole bar, and A plus A means again A bar, means if we apply the A input and we are getting inverted output, means NOR is acting like as a inverter when same input is given. So you can see here A is given, so here we will get output of A bar, and here B is given, here we will get the output of B bar. Okay, again there is a NOR gate. So what will be the output at this point? This will be A bar plus B bar whole bar. Yes, and that this is, if this input is given to the both the inputs of a NOR gate, we will get such inverted output. So this will be A bar plus B bar, and we need to take inverted, yes or no? So you will see this will cancel. So this will be A bar plus B bar. And what is this? This is nothing but, according to De Morgan's law, we can write A dot B whole bar. That is nothing but what? That is NAND gate. Yes. So this is option 3. Very simple question, very basic. Okay, next. Let's go to the next question. That is, in a microscope of objective focal length, f naught is given, f is given, and a t length is given. Now find the magnification produced. Very simple, direct formula based question. So magnification m equal to L into D divided by f naught into Fe. Okay. Now what is L? L is nothing but the length of the tube. That is what? 32 centimeter. Okay. Now what is at normal adjustment? Means we need to take the least distance. That means 25 centimeter. F naught is given as 2 centimeter and Fe is given as 4 centimeter. So just calculate it as 2 and 4 means 8. In 32, 8 will be go 4 times. So 4 into 25, that will be 100. So magnification is 100. Very simple question. Okay, let's go to the next question. That is, in a double slit experiment, the distance means here distance between the slit is 0.1 centimeter. Okay, capital D, distance between the slit and the screen is 50 centimeter. Okay. Now, when one slit is covered with a transparent sheet of thickness D, okay, here one catch is there. In a double slit experiment, we can see that the central maxima is formed at the center of the screen, yes or no? But if one split is covered by some transparent medium, then what happens? The central maxima or other maximum, that means total fringe pattern will be shifted, and the fringe shift, okay, there is a formula, fringe shift, okay, we denote it as delta. That formula will be mu minus 1 T capital D by small d. Let me check this formula. Okay, yes, this is correct. Okay, now what is the fringe shift? It is given as the the central fringe shifts by 0.2 centimeter. That means delta is given, that is 0.2. Okay, next, what is mu? Mu means refractive index. Here n is given as 1.5, so that will be 1.5 minus 1, and this thickness T, and what is the D? Capital D is 50 centimeter. Okay, and small d is 0.1 centimeter. Just solve it. 0.2 equal to 1.5 means 0.5 divided by 0.1, and this is T into 50. Okay. Now this will be what? 0.2. This will be 5 into T into 50. Okay. So if we calculate this, T equal to 0.2 divided by 250. Okay. And if you solve this, you will get T equal to how much? T equal to 8 into 10 to the power minus 4. Okay, centimeter. Yes, option A is the correct answer. Very simple question. Directly question. Okay, let's go to the next question. A collimated beam of light of diameter 2 meter. Okay, means this diameter is given as 2 mm. Okay, 2 mm. Is propagating along x-axis. The beam is required to be expanded in a. This ray should be expanded. Okay, by how much? This will be total 14 mm. Okay, using a system of two convex lenses. Okay, now we can consider two convex lenses like this. Okay, now see what will happen. So this, if parallel rays go, then it will pass to the focus. Okay, this will pass to the focus. Yes or no? Now this will become his focal point. Yes. Okay. Now we need to find what? We need to find the okay. This is lens number 1. This is lens number 2. The focal length means this distance is called the focal length. Yes or no? This focal length f1 is given. How much? F1 is given as 40 mm. Okay. We need to find the focal length of this lens. Means we need to find the f2 equal to how much? Okay. So here we need to find the focal length f2. Okay, by the similar triangle properties, we can use that this length is 2 divided by this distance, focal length f1. That will be equal to this length will be how much? 14 divided by focal length is f2. Okay, so see, focal length of the first lens is 40 and 14 divided by f2. Just calculate it, you will get. Okay, so that will be this will be how much? This will be 20. So 20 into 14 will be 280 mm. This is the answer. 280. Let me check the answer. Yes, 280. Okay, let's go to the next question, that is, if an alpha particle, okay, an alpha particle is there, that means helium 2 plus nucleus is there and it is having some energy, that means it is having kinetic energy. Okay, and we need to find the closest distance from the nucleus. Okay, so here we need to apply the energy conservation theorem, that is initial energy will be equal to final energy. That means initial kinetic energy plus initial potential energy will be equal to final kinetic energy plus final potential energy. Now see, initial kinetic energy, that is total 7.7 mega electron volt, because helium nucleus and the gold foil are way at very far distance, so there will be no potential energy between them. Potential energy will be 0 plus 0. Okay, let's see final kinetic energy, because the helium nucleus or alpha particle will reach to the closest distance, and at that point its velocity will become 0. Yes or no? So that's why kinetic energy will become 0. But there will be obviously potential energy between the alpha particle and the gold foil. Okay, so gold nucleus means, so potential energy formula, what is the formula potential energy between two charges? If charges q1 and q2, if distances r, so we can use potential energy equal to k q1 q2 divided by r. Yes or no? Okay, now see k, what is q1? q1 means charge of alpha particle is, that means nucleus it has only 2 protons, so we can take 2e, so k into 2e. Okay, next and then what is the charge q2? That means charge of the gold nucleus is, that means 79 times e. Yes or no? Because in the nucleus we will have 79 protons, that means 79 e will be the charge of the gold, and divided by this closest distance r. We need to find this r only. Okay, just put the values and solve it. Okay, so that means 7.7 mega electron volt means 7 10 to the power 6 electron volt means 1.6 10 to the power minus 19. Okay, equal to k means how much? K is 9 into 10 to the power 9. Okay, 2 into 79 into, you need to see e and e, that means e square will be there. Okay, so e square will be there, so that means 1.6 into 10 to the power minus 19, this guy square divided by r. We need to find r. Just calculate it and you will get 2.95 into 10 to the power minus 14 meter. 2.95 10 to the power minus 14 meter. This means option A is the correct answer. Okay, so I have solved total 24 questions. I am giving one question as homework. You try it. Okay, you try this question and write the correct option or correct answer in the comment section. Okay, so thank you for watching this video. I hope you like it. Okay, so thank you.